All right, so problem 6-64. First of all, you are given point B, P, and point Q. So point P is 7,2. 7,2 is point P. And point Q is 3,5. 3,5 here is Q. Okay, and sketch vector PQ. So my first question is, does it matter where do I start a vector? So that means, does it matter if I start a vector from Q to P or P to Q, or it doesn't matter at all? Okay, I got, you start with P to Q. Okay, how about the rest of you guys? Even your classmates already put in the answer, but it's okay to retype it. It's just about for yourself to verify the information for yourself. Okay, I got a lot of you say P to Q, so that means it matters, right? So my next question is, what if I start from Q to P? Is that the same? Okay, my question again, what if I start from Q to P? Do I still have the same vector as PQ? Okay, I got no from you guys. I got no, it's not the same because the direction is different. Because its direction is changed. Okay, all right, so that means we have to draw vector from P to Q. P to Q. All right, so that means since you guys bring up direction, so that's the difference between vector and a line and a segment. So vector has direction, and also we have initial point and ending point. So for this vector PQ, which point is the initial point? Thank you, P. Okay, and for you guys, I suggest you guys should have graph and paper and actually work on this problem using graph paper. It's really help you guys be inaccurate on how to sketch vector. Okay, because when you estimate, it's okay too, but when it gets to the point where we mess up with the accuracy on the graph, then it's really hard to tell the magnitude, the directions, or the coordinates of initial point or terminal point. So this is the initial point. And you can put a note for yourself. So where's terminal point? Thank you, Lynn. Q is terminal point. Okay, how about the rest of you guys? You guys agree on Q is the terminal point or ending point? All right, thank you guys. Okay, so we're done with part A. We sketch vector PQ. And if you see the vector denoted by the arrow on top of PQ, that means vector. If we do a problem with vector, and when you mean PQ as vector without putting the arrow on top of PQ, then you lose point for it. Because if PQ without the arrow, it's just a segment with a line on top of it. But PQ with an arrow on top of it, that means vector PQ. All right. So now part B, write vector PQ in component form. What does it mean by component form? All right, I got the answer from you guys. It's 4,3. And we're using a pointy bracket. And some of you say it's just like coordinates. I have 4, -3. All right. I have -4, 3. Any other idea? Okay, some give me -4, 3, 3, 4. Anyway, we just have number 3 and 4 for sure, right? But we don't know which one is the right one. Okay, so for vector is, yes, I agree, it just look like coordinates. However, we use pointy brackets to denote the component form of vector. Okay, so I agree with those of you give me the form that we have pointy bracket and a number, comma, a number, and pointy bracket. All right. So then that fill out the blank right there. So I will have X and Y. So X means you move to the left or right, and Y means you move to the move it up or down. So how do we describe component form of a vector? Oh, thank you, Aiden, for providing me that. X2 minus X1 and Y2 minus Y1, okay? Good to add. So X2 minus X1 and Y2 minus Y1. You will use this formula when you are given 2 points. When you are given coordinates of 2 points. All right. And when we're using graph, how do we write component form based on graph? So then when you base on the graph, you will start with initial point. So from initial point, how do I travel horizontally to Q? I will move to the left 4 units. So 1, 2, 3, 4. And that will give me -4. Because from initial point, have to move to the left, and move to the left means -4. And then from there, I will move up 3 to get to point Q. So 1, 2, 3. And because I move up, it will be +3. So the component form of vector PQ will be -4, 3. So for those of you who got -4, 3, you got it right. And now, if you want to try with the formula, since we already know the coordinates of point P and point Q, you can try to do it algebraically too. I would like you guys try that formula, okay? And tell me, what do you get? Do you get the same thing? Okay, put it in the chat box if you get the same thing. So now label this x1, and initial point, the coordinates of initial point will be x1 and y1. And then the coordinates of the terminal point will be x2, y2. Okay, try it out. And in the chat box, let me know if you get the same thing, like what we got from the graph. Okay, I have few of you confirm with me you still get the same thing. I appreciate. All right, so if we do an algebraically, I have x2 minus x1 comma y2 minus y1, and I just replace by numbers. So I have 3 minus 7 comma 5 minus 2, and that will give me -4 comma 3. So we get the same thing. So no matter which way we do, we get the same answer. All right. Okay. Give me a yes if you understand it, or give me a question if you don't give me a yes. Let me open the participant list. Yes if you understand, or question if you don't. It's like, Miss Wayne, you really confused me. I don't get anything. It's okay to say that. All right, so most of you guys say yes. I guess I can trust you guys. All right, we move on next one. So now we move on the next part, part C. What is the magnitude of PQ? So let not talking about magnitude of PQ, but think about what we already know and focus on my question right now. My question is, can I calculate, let's treat this one at the triangle, right? Can I calculate side QP? Okay, my question again, if you treat the whole thing right here like a triangle, okay, if you treat the whole thing right here like a right triangle, can I find the side length of QP? I got a yes. Yes. Okay, some of you actually give me the idea using Pythagorean Theorem. Okay, go ahead and try it. That's your prior knowledge. You should know, right? Using Pythagorean Theorem. Go ahead, use Pythagorean Theorem and let me know what you get. Wow, I'm impressed. You guys already got the answer. Yes, the answer is 5. I agree with you guys. What did we do? Anyone nice enough to explain? You can type in the chat box or you can unmute yourself and tell me what did you do? Yes, Pythagorean theorem, but what number we use? Okay, I got from you guys 3 square plus 4 square equals c square. All right. So down here, I do to find side QP, use Pythagorean theorem. So a squared plus b squared equals c squared. And we have 3 squared plus 4 squared equals c squared. And we have 9 plus 16 equals c squared. 25 equals c squared. We take the square root, so c equals 5. Right? Hopefully everyone get the same thing using the same method. So what you just found is the magnitude of vector PQ. Okay, so turn out that, oh, there is nothing new. That's something we already know, right? So what you just found is the magnitude of vector PQ. So magnitude of vector PQ is 5. Basically, is the magnitude of vector PQ is the distance between point P and Q. And if we don't use Pythagorean theorem, if we use the component form, anyone can formalize the formula for the whole class. If we use component form, can anyone come up with a formula? No, I don't get any response from you guys. I think you guys kind of get the idea, which is like just not enough to get to the point where you can formalize it. Okay, let me help you out. So for the vector, we have x and y already. So then to find the magnitude of vector, okay, so for this problem, for magnitude of PQ, that's a magnitude notation. And then this will be square root of x squared from the component. So this is x comma y plus y squared. That will give you square root of -4 squared plus 3 squared, and we get the same thing. All right. Did I confuse anyone so far? Any questions so far? You get it? Thank you, Aiden. Okay. All right. So now, part D, the direction. Direction is actually your what is the angle of your vector in standard position. Okay. So basically, we need to find this angle right here. Let me use the highlighter. So standard position means from here all the way to here. Okay, the pink angle. So that means instead of finding the pink angle, I will try to find the green angle first. With the information we already know, can we be able to find the green angle? Okay, my question again, with the information we already know, can we be able to find the green angle? Yes, thank you guys. Using inverse tangent, no, I like that idea, Aiden. Thank you. So using inverse tangent, go ahead and tell me what do you get for that green angle, guys? So to find the green angle, we use inverse tangent. So I will start with tangent of the green angle, which is angle G, equals opposite over adjacent. So inverse means I have tangent to -1 of opposite over adjacent equals angle G, the measure of angle G. Okay, I saw you guys give me 36.9, 36.87. I take all of them. Okay, that's totally fine. But I would prefer nearest 100 because we don't try to round it up too much. Then our answer will be too far from the correct answer. Okay, so I take that as 36.87. That's a fair one. So yes, so I have tangent of -1, and then I have opposites is 3 over 4. That will be 36.80. Sorry, angle G. So then we have 36.869 equals angle G. And Sebastian already calculated the purple angle. Can someone confirm that? Yeah, Calvin confirmed that. Thank you. Ah, Aiden just bring up due to the north. We will talk about that, Aiden. We will talk about the bearing, but not right now. So right now we just talk about the angle in standard position. If you don't put it in standard position, then you have to use the northeast or northwest or southeast, southwest to talk about the angle. But right now we just simply put it as the unit circle. So we use standard position. Okay. All right. But I like the idea you bring it up. So kind of you have the idea about the bearing already. So then the actual angle for the purple angle. So purple angle. Okay. To find purple angle. We have 180 degrees because they are are straight angle together, they straight angle, so we minus what we just found is 36.87 degrees, and we got 143.13 degrees. Thank you guys. So that will be the direction of vector PQ. Did I confuse anyone so far? Okay, time to process and ask me question before we move on. Last one. No question. All right. Last part E. Two vectors are equivalent if they have same magnitude and direction. Give the coordinates of the initial and terminal points of a vector equivalent to vector PQ that has a different initial point. Let me give you guys an example. So I'll give you guys a orange vector. So I have start from initial point will be here, and I call M, and then go 4 up 3. This will be N. So vector MN equivalent to vector PQ because they have same magnitude and same direction. I need 3 more example. Please, when you put in your answer, send it to everyone. So can someone make an example? So my initial point will be negative 2, 1, and terminal point will be negative 6, 4. Okay, Aiden, give me 6, 1, and 2, 4. Okay, let's see. 6, 1, and 2, 4. Yes, I agree. Sebastian, give me negative 2, negative 2, and negative 6, 1. Yes, I agree. Okay, one more. Thank you, Aiden. Thank you, Sebastian. Anyone else? No, no one else? Too tired already? Ready to go already? All right, 8, 3, and 4, 6. Okay, 8, 3, and 4, 6. Yes, I agree. Thank you, Thomas. Thank you, Lynn. Thank you, Saskia. All right, that's it for class today. We will focus more on vector tomorrow. I appreciate all of you guys' effort today. This video will be attached under today agenda in case you want to rewatch it at your own pace. And also I put it under math video. So in case we already go too far from today, you still be able to find it easily under math videos. Okay. All right. I'll see you guys tomorrow. Have a good one, guys. Yes, I do, Lynn. Give me a few minutes for a little break and get back at 2:20. Okay, Lynn?